that, we'll go ahead and start the meeting today. For the record, my name is Stephen Parrish, General Manager of the Regional Flood Control District. Item number 1 is to call the meeting to order. So I will call to order the Stormwater Management Committee meeting today. Is May 11th, 2021. A few housekeeping items. Just to remind the members as we go through the agenda, we request any committee members wishing to make a comment, ask a question, or make a motion that you say your name for the record. We'll open the floor for questions after presenting each item. Also, after a motion is made and a vote is called for, each committee member will verbally vote. If the vote is unanimous, that will be noted. If there are any nay votes, then a roll call will be completed to accurately identify the vote for the record. This meeting was properly posted and noticed in accordance with Declaration of Emergency Directive 006 issued by Governor Sisolak on March 22nd, 2020. And subsequent directives extending this directive for the duration of the current state of emergency. These directives suspend the requirement contained in NRS for a physical location to be provided for meetings of public bodies. Pursuant to Directive 006, a physical location has not been provided for this meeting. A live stream of the meeting is available at the web address on the notice of public meeting. Also, an email address, publiccomment@regionalflood.org, has been provided in the notice of public meeting to allow the public to participate in the meeting. This email address will be monitored during the meeting should any member of the public wish to participate in the final public comment period. Any comments received prior to or during the meeting will be read into the record and become part of the permanent record. With that, we will start with a roll call to verify the members present. If committee member is not present, then I'll call the alternates for a response. Please respond when you hear your name, and if you can make sure you're not on mute, I appreciate that. I'll note for the record that Steve Parrish is present, and we'll call Ed McGuire.
Sorry, Steve, I'm present. Can't find the unmute button.
That's okay. Dennis Cedarberg. And Dennis's alternate, Jimmy Floyd.
Or present.
Jimmy. Mike Jansen. Mike's alternate, Steve Ford.
And I'm here.
And Dale Daffern. And Dale's alternate, Jomel Yamato.
Jomel's here.
Thank you. And I'm showing 5 members present. We do have a quorum. Next slide, please. Item 2 is comments by the general public. As noticed on the agenda posting, comments by the general public regarding items on this agenda were to be posted to public comment at regionalflood.org. Tammy, could you verify if we received any public comments?
Mr. Chair, Tammy McMahon, for the record, there are no public comments.
Thank you, Tammy. Is there anyone on the call that would like to speak during the public comment period? Okay, hearing none, we'll move on to item 3. Next slide, please. Item 3 is action to approve the agenda. The agenda is in order for approval. Any discussion? Entertain a motion.
Ed McGuire move to approve.
Thank you. There's a motion on the floor for approval from Ed McGuire. Any discussion on the motion? All those in favor say aye.
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 Any opposed say nay. And that motion carries unanimously. Next slide, please. Item 4 is action to approve the minutes of the February 9, 2021 meeting. The minutes are in order for approval. Any discussion? Entertain a motion.
Ed McGuire move to approve the minutes.
Thank you, Ed. There's a motion on the floor for approval from Ed McGuire. Any discussion on the motion? All those in favor say aye. Aye.
Aye.
Aye.
Any opposed say nay. And that motion carries unanimously. Next slide, please. Item 5 is action to accept a presentation from the Coanda Trash Screen Technology. We do have Steve Esmond and Renee Gamero here on the call to complete the presentation. So Steve and Renee, when you're ready, if you could take yourselves off mute and you can begin your presentation.
Thank you. I'm going to let Steve take it from here. I have one of my best customer is my 1-year-old son here in the background wanting to give a presentation instead. So thank you for having us. And Steve, I'll let you take it from here.
Okay, Renee, thank you very much and welcome everybody. We appreciate your time and attention. My name is Steve Esmond and Renee Gamero is our partner in Nevada. So with that, we're located in California. Renee's there in Las Vegas. Next slide, please. There's our addresses and so forth. Coanda's got certifications for the, next slide is fine, for the full capture certification designation from the state of California and a number of other jurisdictions throughout California, as you can see here. We've kind of lost sight of those because we do have a global business and we're in several states as well that have certification programs. Next slide. That's the certification letter we received from the LA Regional Board. And it's available to anybody that would like to go online. It's public record as well. Next. We started this company about 12 years ago, and since then it's become a global business. There's a lot of interest in Coanda screens across the world for various uses. Stormwater is one of them. Another is micro hydro. Another is treating raw water, cleaning it up before it goes through further treatment. So we've got a lot of interest in the product as well. And so we're in most of the states. Big in Hawaii, we're on all of the islands in Hawaii, Alaska, South and Central America, Africa. Europe right now is pretty hot. We've got a lot of business in Europe and had some in the Pacific Rim as well. Next slide. We get asked a lot about Coanda, and this gentleman here, Henry Coanda, was a Romanian inventor who actually pioneered the field of aerodynamics and explained through his research the theory of aerodynamic lift, which enabled the development of helicopters and other flying machines. At the same time he did his research, Wilbur and Orville Wright were actually playing around with their actual airplane. And so the Wright brothers developed the technology that Coanda was working on from a theoretical basis, but there have been over 200 patents that came out of the work of Henry Coanda, and we've got about 5 or 6 patents ourselves from his work. Next slide. The technology works this way, and when I say Coanda, the Coanda screen is different from every other screen. I think you'll see that maybe on the video at the end. If you'll stay for that, that will probably help clear up some questions. But instead of removing trash from water, we remove the water from the trash, which is a big difference, and it is a distinction. Water flies across the face of the screen instead of toward the screen. When you look up close at a Coanda screen, this is it right here. You can see it almost looks like a plate. But every wire on there is a V-shaped wire, and they're all tilted before they're welded onto the backer rods that support the wires. So the water goes through each opening of the screen as it moves downward. So normally the screen is mounted on an angle that would be something like around 45 degrees. 35 to 40 degrees is a pretty common angle. So the water goes through the screen, trash and debris just move down the face of the screen and slide off the bottom. So the trash never has an opportunity because of the tightness of the screen. Then I'm holding a 1 millimeter screen. This is the popular size that we're using in most cases. We've installed a lot of 1/2 millimeter screens, and there are various sizes, but this is probably the sweet spot in terms of trash. Next slide. This is a connector pipe screen, which is grown popular because of its cheap cost, and it's it's made of perf plate. I'm holding up some perf plate here. This is just a plate of steel with holes punched in it, and here that kind of screen is like every other kind of screen out there. The trash and the water compete for the same open space, and before long during a storm. This is inside a vault. The water and the trash will move up against the screen, plug it, then it has to be clean. You're looking at one that's in service here, and you can already see that it's partially plugged. So according to the 40% rule that's been adopted in LA County, they've got to send crews in to clean this screen at this point. Next slide. We don't have this problem with Coanda screens. They stay clean. It's a self-cleaning screen because of the way that it works and the fact that we do get the Coanda effect acceleration through the wires. It's a self-cleaning screen. So there's no need to clean the Coanda screen, unlike this screen or any other conventional screen that you'll find on the market. Next slide. You may have seen these around. They're fast becoming unpopular. A number of cities have moved away from them, but there's still some out there. We call them excluders, but there's some kind of a screen that goes over the inlet of a curb inlet, the inlet to a curb inlet. And these accumulate trash and, of course, start to block and plug up, and then you've got water standing in the street. Next slide. The advantages of Coanda screens are pretty well expressed by the United States Bureau of Reclamation, which is a federal agency headquartered in Denver. They've tested Coanda screens extensively and have been advocating them and actually using them throughout the West. And what they say about these is these screens have large flow capacities, are hydraulically self-cleaning without moving parts, and require minimal maintenance. So if these guys can be trusted as an authoritative source of information based on this conclusion, this seems like an ideal perfect storm for something that might be of interest. Next slide. There is no accumulation of trash with the way we have them configured in curb inlet vaults. This is one right here. Usually they're alongside the curb, and they have an opening that's probably 6 to 8 inches tall and a width of several feet with a manhole access into the vault. Next slide. What we do is we insert the Coanda screen inside and basically build it from end to end. So it's a full width screen, and on the bottom part, you'll see a vertical steel wall. By the way, this is all stainless, but we do use perf plate on the bottom vertical wall. It's called a debris fence, and we build it out of the perf plate material. We stiffen it to make it rigid so that it will meet the building code requirements, and it has essentially the same rigidity as the concrete wall. So we expect this to last decades of service. We've never had, our oldest installations are now over 10 years old. We've never had any fail or break or any plugging or any problems with them. So you can see there the Coanda screen is at an angle. Water flows off the street from the gutter. It goes right across the face of the screen, and water goes down through the screen, and the debris slides down onto the right side and falls in the bottom, from where it can be picked up with a Vector truck and hauled away on a periodic basis. And most of our customers clean their vaults a couple of times a year. Next slide. Well, there's some more typical installation. They all get to where they look about the same, actually. Next slide. We've got channel screens as well. These are bigger screens. They're end of pipe screens is what we call them. And they are different orientations. We say online or inline or offline, but they're designed for large flows. And these have become really more popular, I guess, lately for clients that want to treat a lot of flow at one point instead of in each curb inlet. So we won a stormwater project of the year a while back with this project. Next slide. And other ones at different places. This one it's an offline channel. So what happens in the main body of that you can't see upstream, but when the water level picks up and it'll flow across the screen. The water goes through the screen, trash comes off the face and falls into that little area between the handrail and the screen. And there, to clean it, all you need to do is move through with a wheelbarrow and some tools and pick up the trash that's accumulated. And if it's a lot, you can use a small bobcat or something like that to scoop it up. So very, very simple way, very easy. People don't have to climb inside vaults and deal with confined spaces in these channel screens. And that, I think, accounts for a lot of their popularity. Next slide. This is a channel screen. It's the largest stormwater treatment facility in the world, 1,200 CFS of actual Coanda screen capacity. And it's at the headwaters of the Rio Grande. It's actually an international project, but this just shows that they can be scaled up to a very large size. Same exact principle. Next slide. One here in California. This is in a channel where it's right at the head of Newport Bay, and it feeds into Newport Bay. So to comply with the trash mandate in California, they wanted to do an end of pipe system here rather than have numerous vaults. And so we went into this channel, took out a section of the wall right where the screen is, and moved and rebuilt a wall back behind it, put the channel screen in, and then now this channel screen is treating all of the low flow. By the way, the low flow in this particular channel is like between 1 and 3 cubic feet per second. They get that dry flow all the time because it's from fugitive runoff from car washes and air conditioning condensate and other things like that. So it's a fair amount of flow, but they take that water that goes through the screen and direct it to reuse. There's a golf course nearby, and they have some other options with respect to reuse, but that water can be reused. And then, of course, with large storms, this screen will treat up to 100 CFS. So it is a pretty big screen. There's a total capacity in that channel is 1,200 CFS. So there's a long-range plan, if the county ever wanted to do this, to build more of these next to each other. So we could go and offset further downstream and put in more of these to get 1,200 CFS of capacity installed. Next, oh, by the way, back up there, the ramp there is to facilitate vehicles to move through, scoop out trash and haul it away. So it's, again, a very easy method of cleaning. We don't know anybody that's actually having to clean the screens. I mean, there might be a little debris sitting there, but it would fall on its own into the debris area and be picked up. Okay, next slide. Urban trash. I know you've probably seen a lot of this, and this is just a shot from downtown LA. Still have a lot of green waste, even in a place like LA, and of course, I'm sure in Clark County as well. But a lot of anthropogenic, wrappers and cans and all kinds of things. Next. There was a University of Southern California they tested our Coanda screen and found that we're capturing a lot of sediment, seeds, and so forth, mulch, finer material, green waste, leaves and then trash, which is bigger, but it is small enough. It's a small screen. The definition of trash, by the way, is 5 millimeters. So we're down in a size that we're not only removing trash, but we're removing much of the smaller material as well. Next. We think that our screens are going to last 30 to 40 years. Like I said, we've been in our oldest installations are a little over 10 years now, but LA County certified that they would last at least 10. Bureau of Reclamation says more than 20, but they don't they don't put a number on it. So it remains to be seen how long these last. I will say this though, Bureau of Reclamation actually pioneered a screen back 50 or 60 years ago in Colorado, and that screen is still in service. So These could last even beyond 40 years. Next. Based on cost comparison, this was a study that was done by HDR, I believe, comparing on a life cycle cost basis. Now, Coanda screens are pretty expensive initial cost because this is stainless steel. It's not cheap. It's stainless, and the way that it's made, it's expensive to make these. So about 2/3 of the total cost of the Coanda screen is just in the material. But when you calculate the life cycle and the basis would be the cost to remove 1 pound of solids, then we start to look really cheap. And on that basis, by the way, it includes amortized capital cost and operating cost as well. So all those numbers are rolled into this. So you see that Coanda is, street sweeping has us beat, I'll admit that. But next slide. These nets are kind of intuition would tell you that they're effective at removing trash, but the difficulty is that, of course, they plug. There's a finite size on this. Basically, it looks like a sock, but it's a net, and the water goes through that when it can, but when it's full, it can't go through that anymore. So there's a lot of labor, and this is a very heavy thing to do and physically challenging to remove those and replace them. Next slide. Down at Long Beach, they've got booms and various booms. They've tried this for years because they're still not capturing all the trash upstream of the tidal basin. And this is the last point at which trash just goes straight into the ocean at this point. So you're looking in the tidal zone right here, and the nets are, I would say, remarkably effective, it looks like, in terms of capturing trash. But then again, you do have a big labor-intensive job of hogging that material out, disposing of it, then replacing the booms and so forth. So that's another aspect. Next slide. Water Sharks has been in business since 2005. We've got over 30 years of experience, but we can also do site-specific things like sediment removal. We can focus on nutrients and things like that. Even some nutrients are coming out in the smaller screens, particularly the 0.5 millimeter screen is where you want to go, and even smaller than that on occasion we've gone. So next slide. Any questions, comments? If you want to see the video, I think the video would help. If you don't get to see the video, then I'd encourage you to get the link or to go on our website and to look at it. Is this the video now coming up? Yeah, there it is. I'll just talk through this. This is a cutaway view. It's a plexiglass unit that we built to show how the screen works. It looks like a curb inlet with water flowing on the street, then it comes into the screen, onto the screen, and down. Here you're looking straight ahead at the face of the screen, and notice how debris and trash are coming in, and they basically are sitting on the screen right now, but because of the angle of the screen, they'll eventually fall down into the debris compartment. And so you see the arrows too, indicating the direction of flow. So the water's going through that screen at about less than halfway down the screen. And the trash can just, once it's in the bottom, once it hits the screen, it's been trapped. And so then it's going to be picked up with a Vector truck or either hand tools or something like that and removed. There you see it sitting on the face of the screen. Sometimes we'll see this after a storm. After a little time, it dries, and when it's dry, it'll just fall right on down into the bottom because it's sitting on a steep angle there. So, by the way, we do pride ourselves in treating the full flow. In California, the design standard is the 1 year, 1 hour storm, but we typically design these for peak flow. My contact information and Renee's are right there. Renee's local. in Nevada, and I'm in Southern California. So feel free to reach out to us afterwards, anytime, and our email is there too. So if you have any questions or comments, we'd be happy to talk to you.
Thank you, Steve. One of the reasons why we wanted to have Steve and Renee here to present to you is because Clark County Water Quality is preparing a grant-funded proposal to the Nevada Division of Environmental Protection 319 grant program for a pilot project to assess the effectiveness of the Coanda streams in select drop inlets and detention basin bypass structures. Clark County Water Quality is working closely with Clark County Public Works and Regional Flood on the proposal, and may also reach out to other MS4 co-permittees to participate in the assessment. So we wanted to present it to the SQMC to make sure that they were aware and of what we were doing in the project as we move forward, so that you weren't surprised by it and had some information about it before we get too far along.
Okay, thanks, John. Any questions from the members or anyone on the call for Steve? I have a question. I know that you showed I think it was the Rio Grande was one of your larger applications. I'm assuming that and maybe this is getting a little too technical, that the water has to be flowing in a subcritical, I would assume, situation, because we have a lot of concrete channels here and higher velocity flows, supercritical flows, and we always worry about having an obstruction in the channel during a higher flow event, and whether or not that would affect the hydraulic capacity of the channel. And so we haven't figured out a good way to get around that yet. And so I was just curious if you guys have thought about that situation.
Larger objects right in the channel. I think what, in Albuquerque, what they've done there, and they've got some capacity upstream to actually go in and take large objects out of that channel before it reaches the screens after the storm has passed. But if those objects continue on down, they'll basically come on and flow across. They'll hit the screen and maybe come down the face of the screen. We had a situation, and it wasn't a stormwater installation, but it was a diversion of water diversion in Northern California, where a boulder came. It was a partial landslide came, and the boulder rolled across and damaged one of the screens. But we put these screens in roughly, typically around 4 foot wide sections. So the screen you're looking at, it might be 40, 50, 60 feet long, but we build them in 4 foot sections. So it did some damage when it hit the screen. Again, this was a boulder, but we just made a 4 foot section and shipped it to them, and they installed that section. So it wasn't a terrible problem. Here in that Orange County project that I showed you, we're at the flow line down at the bottom of the channel. So we're seeing some things, probably as well as anybody what you have in your runoff, but large, big objects, mattresses, furniture, all kinds of stuff can get in there. The screens are pretty durable, and they are designed for a pretty heavy load. And they're smooth. So it takes a lot to damage the screen, and plus it's on an angle. So if something tries to come across it, it's going to be a glancing blow. But yeah, I think those removal of large objects like that has to be done kind of maybe upstream of where the screen is, or if it does come down and pass over the screen, then it can be picked up below the screen there and hauled away too. So did I get to the question that you had, or the concern?
Yeah, that's fine. Yeah, I think so. Thank you.
Okay.
Any
Sure.
other questions?
Hi, this is Jamel. Stephen, I saw from your video that water seems to be captured 100%, even though debris sits on the screen until it gets, gravity's down into the actual catch. As far as maintenance of these screens, do you have scheduled maintenance on these, planned maintenance on these screens? It seems like you have very little or zero clogging factor on these screens, right, Stephen?
Right. We don't do any, we've never seen any of our customers do maintenance on the screen in terms of pressure washing, or I'm trying to think what would be done, maybe scrubbing it or something, but with a brush. We don't see that. We don't really even recommend it, but if people want to take a broom to the screen and, there's no problem there if you want to, but once debris comes in and it's on the screen, it might sit there for a while before it falls just by gravity into the bottom, but it has, at that point, it's been captured and it's going to wind up in the bottom. If not fairly soon, and certainly the next storm that comes through will push the water, or push it on down into the bottom.
Thank you.
Sure.
Okay, any other questions?
Yes, this is Eric Su. I have a quick question. It seems like the device itself is kind of dictated by the flow depths on top of the screen. Is that the right assessment?
Typically what we have for the curb inlets, most curb inlets are, I know in LA County, their standard curb inlet height is about 7 inches. So it's 7 inches of water from the flow line of the gutter up to the top where the sidewalk would be. So you've got 7 inches of flow depth.
Correct.
And so that represents about 1 CFS per foot of width. So that, and you can get more granular and define that number a little better, but typically that's what you come out with, is about 1 CFS per foot of width. On these large channel screens, now you can have several feet of water, and we'll have from time to time a large flow. 100-year storm is going to, if you remember that slide on the Santa Ana River above Newport Bay, that is going to fill up someday. 1,200 CFS is going to come through there. And we're not set up to treat 1,200 CFS. So the screen will continue to treat 100 CFS, but the rest of it would just go on right on downstream. The concept there is that we're treating the first flush, and we're treating that's where the major concern seems to be, is that first flush. There's no interest in the part of the state or the city or county to treat the entire 1,200 CFS storm, that 100-year storm. So just to get it through and let it pass on through. We want to understand the hydraulics. So have I answered your question?
Yes, I think you can confirm that the depth definitely play an important role in this case here to see the efficiency of the debris remove rate. But I think you just mentioned on the urban environment, if the curb opening or the grade is about 6 or 7 inches, that seems to be a dictating factor.
Right. That determines how much water can actually get into the vault.
Sure.
And if that would be the limitation, in fact. So if more water than that can't get in there, then we size our screen on that basis, and that's kind of what we do. That's the design concept that we use for the curb inlets.
So for the open one, like the one you just show on the slide, in order to again, it's to treat the first flush, but in order to make it more efficient, you have to make that screen as long as possible. Literally, just make the sheet flow over the screen. Is that correct?
Right. We'd have to build, the one I showed you was a 100 CFS screen. So we'd have to build the 1,200 CFS channels. So we'd have to build 12 of those in a series.
Sure.
to be able to treat the whole flow, but I don't think the county would ever need or want to do that, but again, their concern from a regulatory agency viewpoint is the first flush.
Understand.
And getting that trapped, getting that debris out.
Well, thank
And
you.
I think this is Renee, and I think I caught a part of your question too was it potentially the height? And correct me if I'm wrong, Steve, here, but for that to work, for the screens to work most efficiently, you need maybe the minimum 2 feet of height differential, and the screens usually end up being positioned somewhere between 30 and 40 degrees, but that's something we calculate for we manufacture.
That's a great point, Renee. And we need a vertical change in elevation through the screen. As you saw in that video too, you can see that. There we had maybe not even a foot, but that's a small unit. But we like to have a foot or two of vertical elevation change to make where the Coanda screen can go through. We need an open channel flow condition so it'll work properly.
Thank you.
Sure.
Thank you.
Any other questions? Stephen and Renee, I really appreciate the presentation. Thanks for taking the time to come talk to us this morning. With that, I would ask for a motion to accept the presentation.
Steve Ford, move to accept the presentation.
Thank you, Steve. There's a motion on the floor from Steve Ford to accept the presentation. Any discussion? All those in favor say aye.
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 Any opposed say nay. And that motion carries unanimously. Thank you. Item 6, next slide, please. Item 6 is action to accept a presentation and receive an update on proposed water quality standards for the Las Vegas Wash for selenium. I think John was just going to speak to this item for a few minutes, so I'll turn the floor over to John Tenner.
Yes, so this is just a brief update on where we're at with the selenium project that we've been working on. Right now the status is we presented data to the US EPA back in November and then again in December, trying to convince them that we had sufficient data to move forward to develop selenium water quality standards for the Las Vegas Wash. EPA since come back and has said that they don't want to, they want us to collect additional fish. So we will be moving forward with that process to collect additional fish to do selenium sampling on. That sampling is scheduled right now to take place in August in the Las Vegas Wash. So we'll be collecting carp in the Las Vegas Wash to do selenium sampling. We are also working on a process to delist the tributaries to the Las Vegas Wash, the main tributaries to the Las Vegas Wash from the 303D list. Work to do that requires the development of what's called a use attainability analysis, and that's an analysis that looks at can the beneficial uses that are designated for those reaches actually be obtained. And so the first step in that is to do some field reconnaissance work. The consultant team will be in Las Vegas at the end of May for 3 days. To do that field reconnaissance, that involves taking pictures, examining the substrate of the channels, taking some water quality samples, and doing some analysis of that just to get a view of the lay of the land before we begin to develop the use attainability analysis. So that'll be taking place in May as well. So with that, that's all the updates that I have on that project. If there are any questions, I'd be happy to answer them.
Any questions for John? Okay, this is an action item, so I'd ask for a motion to accept the presentation.
Ed McGuire, motion to accept presentation.
Thanks, Ed. There's a motion on the floor to accept the presentation from Ed McGuire. Any discussion on the motion? All those in favor say aye.
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 Any opposed say nay. And that motion carries unanimously. Next slide, please. Item 7 is action to approve the Regional Flood Control District to negotiate a consultant contract with HDR Inc. for the National Pollution Discharge Elimination System permit compliance for the Las Vegas Valley. We've been using HDR now for 4 years. They've been doing a great job, so we're planning on entering into another year's contract with them for the 21-22 permit year. Any questions or discussion on that? Entertain a motion.
Motion to follow staff's recommendation. This is Ed McGuire.
Thank you, Ed. There's a motion on the floor for approval from Ed McGuire. Any discussion on the motion? All those in favor say aye.
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 Aye. Aye.
Any opposed say nay. That motion carries unanimously. Item 8 is to discuss the FY 2021 quarterly reports and take action as deemed appropriate. We did receive the Q3 report from the members. The information is looking good, and that we're on track to meet our requirements for the year for the permit. I wanted to note that our stormwater PSA is running again this month in May, and I think it'll run into June on all the major networks, and I think on Telemundo. So you should be seeing our stormwater ad throughout the month. Any other questions or discussion? Anything else anyone wants to bring up regarding your respective entities? Okay, hearing none, this is just a discussion item, so we can move on to item 9. Next slide, please. Item 9 is to discuss monitoring activities and issues and take action as deemed appropriate. Dry weather monitoring, is there anyone from SNWA on the call? Todd or Xiaoping? I don't hear anyone. In terms of wet weather, we haven't had much wet weather, but Angie, is there anything to report?
There is nothing to report. It's amazing that we haven't been out sampling, but we are absolutely ready to go with any rain that we can pick up.
Okay, thank you. Any other comments or questions regarding item 9? Okay, hearing none, we'll move on to item 10, which is to discuss Nevada Division of Environmental Protection issues and take action as deemed appropriate. We did receive a draft of the new NPDES permit. We are reviewing that along with the other committees at each of the entities and preparing some comments to send back to the state, which we should have those done pretty soon, I think. Any other comments or questions or anything from anyone from NDEP have anything to talk about?
This is Alex Mayorga from NDEP. I had nothing further to discuss.
Okay, thanks, Alex. Any other comments or questions? Okay, move on to item 11. Item 11 is to discuss other stakeholder issues and take action as deemed appropriate. Do we have anyone from NDOT on the call? Or Nellis Air Force Base? Any other stakeholders that would like to speak on this item? Very good. Move on to item 12, which is to discuss items for the next SQMC agenda. Is there anyone that has any items that they want to add to the agenda for the next meeting? I will point out, I'm not sure whether we'll have an agenda item or not, but John Tennant is working on an update to the stormwater website. So we're freshening that up and getting it up to today's standards. So that work is ongoing, and maybe we'll have an item next time that will just give you an update on that. Any other comments or questions on that item? None. Move on to item 13, which is comments by the general public. As noticed on the agenda posting, comments by the general public regarding items on this agenda were to be posted to public comment at regionalflood.org. Tammy, could you please check to see if we received any public comments, and if so, read those into the record.
Mr. Chair, Tammy McMahon, for the record, there are no public comments.
Anyone else on the call that would like to speak during the public comment period? Okay, hearing none, that concludes our posted agenda. Thank you everyone for tuning in today. We appreciate it, and this meeting is adjourned.
Thank you.
Thanks, Dave.
Thank you.
Thank you, everyone.
Thanks. Bye-bye.
Thank you.